Example, given system of equations 5/6 times x minus 1/3 times y equals -5. That's equation A. And -x plus 2/5 times y equals 1. We'll name that equation B. So given this system of equations, we'll find solutions using either substitution or elimination. So we'll use one of these two algebraic methods to find our ordered pair solutions to this system. Okay, now before I decide which method I'm going to use, I do not like fractions, and when I have an equation, in other words, I have an equal sign in my statement, I'm allowed to get rid of the fractions by multiplying both sides by the LCD. So let's make a little dot here. Eliminate fractions first. So I don't always start like this, but in this case I just want to get rid of them. So the first thing I'll do is I'll notice that with equation A, it has a least common denominator equal to 6. So if I multiply both sides of the equation A by 6, it'll get rid of my fractions. So there are two terms on the left side. Let's multiply both of those terms by 6. 6 times 5/6 times x minus 6 times 1/3 times y. Now multiply the other side by 6 equals 6 times -5. Okay, now you'll see that we cancel a 6 in the first term. We cancel a 3 in the second term, leaving a 2 in the top, in the numerator. And that gives us our new version of equation A. 5x minus 2 times 1 times y is minus 2y equals positive times negative is a negative. 6 times 5 is 30. This is my new equation A. Now let's do a similar thing to B. For equation B, the least common denominator, LCD, is just the only denominator, 5. So we'll multiply both sides of equation B by the LCD 5. 5 times the first term on the left, which is -x, plus 5 times the second term, 2/5 times y, equals 5 times the other side. Okay, now when we simplify this, you'll see a cancellation in the second term of the 5's. We get a positive 5 times a negative x is -5 times x. Bring down the plus sign. 2 times y is 2y. Bring down the equal sign. 5 times 1 is 5. And that's my equation B. Thus, our system is, now this is just simplified. The first equation, 5x minus 2y equals -30. That's my simplified equation A. And -5x plus 2y equals 5. That's my simplified equation B. Same system, just got rid of the fractions. Okay, now we're ready to follow the steps for solving, and I think it'd be best to use elimination. Use elimination method. Okay, so step 1, choose to eliminate I have to choose one of the variables, and I'm going to say x. Okay, I'm going to eliminate x. And how am I going to do that? Step 2, I'm going to do that by just adding. You're supposed to add a multiple of one of the equations to a multiple of the other in order to get rid of the variable you've chosen to eliminate. Well, it's only going to require that we just add a and b together, and you'll see that that's going to make our x's disappear. So equation A is 5x minus 2y equals negative 30. Equation B is being added to that, negative 5x plus 2y, bring down, equal sign then of 5. Okay, now let's add these together. Now we did this to eliminate the x, and sure enough, 5x plus a negative 5x, they just cancel each other. But look what happens to the y's, something that we didn't expect. Negative 2y plus 2y is 0, so those also cancel each other. I didn't expect that to happen. That means the entire left side is going to be 0. Bring down the equal sign, add the right side, negative 30 plus 5 is negative 25. And you'll see we have lost our variable. There are no more x's and no more y's. We are stuck. We are stuck at, now look at that, 0 equals negative 25. That's never true. So we are stuck at a never true statement. That's not the answer to the question. It's just an observation. We are stuck. We lost our variables. And where are we stuck? We're stuck at a never true statement. So let's draw a conclusion from that. Thus, okay, if we're stuck at a never true statement, that means there are no solutions to this system. And when we have no solutions, it is an inconsistent system. So I can say there are no solutions. For the system. And the way we say that is that it is, the way we write that is, for number 61, we either write the set of all solutions is empty by writing the simple empty set, or you may write the curly set brackets with nothing in them. And we're done.